Welcome to Walkabout the Galaxy, the unconventional astronomy podcast where, ironically, the show is going to two conventions.
Oh.
The science is universal, the opinions are personal, and the trivia is all about Uranus.
Nah.
And that's
ready for a decade of those?
I know, right? I couldn't believe how much I was hearing that on the radio in the last week. Yes.
People mispronouncing Uranus?
Do they always say Uranus?
Yes.
They often do.
Non-scientists always say that.
Yeah.
And it's just painful. I'm like, you don't... If you want to make a stupid juvenile joke, like I just did, by all means. But if you're trying to carry on a civil conversation, don't you not want to make that sound? You know, don't you? There is a perfectly suitable option.
Yeah.
Which we will talk about later. We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida, Top Quark is busy with a new baby quark.
Excuses.
Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Check out our hashtag shorts on YouTube, where we have introduced Hannah Sargent's blind date theory to explain the Fermi paradox. We are also at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu, and definitely do contact us that way if you order a shirt so we can get it to you as soon as possible. Our stumper today is inspired in part by some of our nerd news, which is related to the Moonknight series.
Moonknight.
Oh, do I need to watch that as well?
It depends.
I wouldn't put it... I mean, I'm enjoying it, but you're so far behind on so many different...
But it's pretty standalone, too.
Is it Marvel?
It's Marvel, yeah.
Okay.
But it's pretty standalone so far, at least.
Yeah. I'm just saying, it depends if you're trying to, like, up your general literacy level. There are other things that I would consider more foundational than Moonknight.
I love all the backhanded, like...
That was pretty front-handed.
Yeah, okay.
Actually.
Yeah, that's just rude.
Anyway, Moonknight has inspired our stumper for you, which then turns into one of these sort of philosophical things. So maybe it's not really a stumper.
I don't know, it's a...
In Minority Report by Philip K. Dick, great author who wrote the book which inspired the movie Blade Runner. Maybe Hannah's even seen
None of the above.
Minority?
Really?
Have you seen Minority Report with Tom Cruise?
When I was young.
Yeah.
Probably when it came out.
Yeah.
I don't remember
but not
anything
Blade
about
When you
it.
were young.
No.
Yeah.
Oh, you
well,
haven't seen
okay.
Blade Runner?
Well, anyway, Philip K. Dick wrote wrote a novella or a longish short story called Minority Report, which was made into a movie with Tom Cruise, directed by Steven Spielberg, in which a group of three people have the supernatural ability to determine that somebody's going to commit a crime in the future. Precognition. And they report that to the pre-crime police bureau.
Pre-crime.
Who go and arrest people preemptively.
Yeah.
And it turns out to work just swimmingly well because crime rates plummet.
Sure.
So there's something to it. In the new Moonknight series, there's some sort of proxy war or war between a couple of Egyptian gods or spin-offs of Egyptian gods.
Yeah.
One of whom, to my limited understanding, punishes people who have been evil.
Yes.
And the other of whom decides through some magic in advance that you're gonna be bad.
They're precog.
And kills you.
Yeah.
So the question is, in both cases, the future evildoers are punished before they commit any wrongdoing, once by the Egyptian god Ammit and the other by the precogs in the Minority Report. What's your take on preemptive? If you had this magical ability to preemptively
It's like an ethics
identify.
question, not a stumper, I feel like.
I'm trying to get to terms with the films and the stories and now decide my stance on it.
So putting the stories and films aside, basically, like, if you could know that in advance or could predict that someone was going to commit a crime, and
How do you feel about locking them up?
without them having committed
But they
it.
haven't done anything bad yet.
Yeah.
This is where I draw on my knowledge of a TV show that I have seen.
Okay.
Oh.
The Good Place.
Oh.
And, bad people can be bad and do bad things, but if you give them the opportunity, they can be good. So if you think that people are going to be bad, then some sort of rehabilitation to prevent that or whatever, rather than just
like an intervention as opposed to
yeah,
an arrest.
Right.
exactly. Yes, I'm on the stance of intervention.
That's why I was thinking it's not really a stumper because, of course not, right? We
Just-
you
It might be
No.
for some people. I don't know.
Well, maybe you do something.
Yeah.
You do something, but
Yeah. It's
like some career counseling.
there's a little bit of that in the last season of Westworld too. I feel like I'm trying to. That was tickling a brain memory.
Yeah.
There's this like a giant AI thing, and it.
That's right.
And they're like controlling the population.
That's right.
Basically, it turns
That's right.
out, and part of that is knowing who the bad people are going to be, and it turns out they're like locking people up.
Yeah.
And I don't know.
It's generally portrayed in all these science fiction things as not such a good thing. So it's not
Usually
super
backfires.
It's not super stumpery.
Yeah.
Yeah. But I was just thought it was interesting, and Moon Knight made me think of the Minority Report. Mm-hmm. Well, today we'll talk about the new Decadal Survey for Planetary Science. Do you know how often those come out?
Roughly.
On
Is this a
average.
trivia question?
This is your trivia question.
On average, every 10 years.
Yeah.
And I was wondering, has there been a delay? I can't remember when the last. I don't know.
A
when the last one-
COVID-ish
Yeah, was
delay?
there a COVID delay at all?
No, I think this came out like a few months after they were hoping, but not like
because it's
significant
usually
COVID
like
delay.
pre-LPSC conference, I
Maybe.
think, and then they, I think they try to announce it at that conference. It's a big lunar planetary science conference, but they just had to overshoot it by a few weeks or a month or so.
A month.
Yeah. So that report's out, all 800 pages, which we will read on the show, word for word. No, we won't. But first, this episode of Walkabout the Galaxy is brought to you by PN Junctions.
Oh,
I'm sorry. It's short, Addie, so don't worry.
okay.
PN Junction, what's your function? Hooking up holes with free electrons. PN Junction, how's that function? I got semiconductors made with silicon. PN Junction, what's their function? Can be PNP or NPN now. I got diodes, transistors, and Schottky junctions. PN Junction, what's your function? Sponsoring Walkabout. That's what's so fun.
What is that tune?
PN Junctions, we bring good things to life.
Conjunction.
It's not, I think, tune, I'll take it as a compliment.
What were you aiming for there?
Conjunction Junction.
It's maybe that's an America thing.
It's a Schoolhouse Rock song.
Yeah.
Conjunction Junction, what's your function? Hooking up phrases with and or and but. Conjunctions.
That's how you learn about
It's one of these.
Oh,
one of
right.
these
Oh, it's like an
kiddies.
education thing.
It's an educational kiddie song.
Schoolhouse
Yeah.
Rock was educational kids
And
song.
I made
Right.
I made zero attempt to actually figure out the rhyming or the thing or whatever.
It was a little rough on that.
Yeah.
Yeah, and the rhythm or
You mean
anything.
the sponsor made little attempts to
Of course,
do that.
that's what I mean.
And what was the,
I will
what's
say
the
that-
tagline?
We
what's-
bring good things to life.
Oh, you didn't say that.
I did, but we were already off on explaining what Conjunction Junction was. We bring good things to life.
3M? No. I can hear it in my head.
Yeah.
Is it some sort of TV?
It's related. They make TVs, I think, or they made TVs.
Is it
Like LG. Oh, no, that's Life's Good
but
or
it
something.
has a G in it.
Samsung?
GE.
GE. Oh, yeah.
GE.
GE.
Yeah, General Electric.
Oh, okay.
Yeah.
Good things to life.
Well, in any event, sorry about that. PN junctions are in semiconductors.
Can I have you come sing that to my class in the fall? When we're learning about...
Oh, did you do,
Maybe.
like, are they like solar cells and
I
stuff?
will say that our next music
how
video,
you
which
make
I have been
semiconductors.
teasing for some time, is definitely better than that.
Excellent.
It has a real melody.
Great.
The words fit the melody and go together.
Great.
And
This wasn't a sneak
are
preview
nice,
then.
And I will not be singing it.
Oh, that's too bad.
even-
Oh,
even better.
shucks.
I won't even be attempting to sing it. I couldn't even really call that singing.
It was
I was sort of
melodic.
hesitating about whether I would even try to make it other than just reading it.
It was fine.
I'm glad you put in the effort.
Yeah.
Thank you. So we mentioned Moonknight,
Moonknight.
and then the other moon thing that we've talked about is Moonfall, and we're planning a
Yes.
Astrocork narration or
Yeah,
commentary.
live commentary.
Live commentary.
We won't have seen it before, so
Yes.
you'll be seeing our live
Spontaneous
reactions.
Yeah. And then speaking about science fiction-y stuff and mentioning that this was the unconventional, ironically conventional podcast.
Yes.
Because we will be recording an episode in just a few weeks at MEGACON 2022.
Woo!
In Orlando, Florida.
Yeah.
And I was looking at who was going to be there, and there's a lot of cool people. I did not appreciate how big this conference is.
Yeah.
I'm excited.
Yeah.
All of
It's a
the
big deal.
hobbits. All of us.
All of the hobbits.
All of us. I mean, we
The
are
three of us will be there.
prime time
Yes.
entertainment.
Yes.
Yeah, all the hobbits are going to be there. Well, the main hobbits.
I hope for
hobbits,
Elijah
not all
Wood's
the
sake
hobbits.
that they don't schedule him opposite our
I
recording
know.
of Walkabout the Galaxy.
Yeah.
I should go say hi to Elijah Wood because he and I are co-stars
In Deep Impact?
in the movie Deep Impact.
Deep Impact.
Yeah.
Wow.
Yeah.
Did you meet him?
I did not meet him because we didn't share any scenes.
Yeah, you weren't in any scenes.
Yeah. I was in the space scenes. He was an Earth boy. We will also, later this year, be making a second convention appearance at DragonCon in Atlanta.
And you've been to these before, right? So this will be my first time at these at any Comic-Con.
Sort of convention.
Comic
at all.
convention ever.
Right. Yes.
Yeah.
And you'll be going in cosplay, we've decided.
Well,
We'll see.
we'll see. Only if you do.
Okay. Deal.
We're working on it. I'm working on it.
I
Yeah?
will.
Yeah, his is easy. He just has like Star Trek costumes.
Oh, right. I have nothing, obviously.
Yeah.
We'll figure something
We'll
out.
figure something out. What? And you're
I don't
still
know yet.
thinking, okay.
Maybe I'll be Moonknight. Oh, sorry.
Yeah. Okay. So the Decadal Survey is commissioned.
Wait, we didn't talk about Moonknight at all. Or Space News. I don't know. There's not much. There's some launches.
Yeah.
More rockets.
More
rockets are going up.
They delayed the Axiom crew from returning a little bit because of bad weather. And I heard somebody ask, like, do they have to pay more since they stayed a
know.
couple
Oh,
extra
yeah.
days?
And I think
It was
It might have been Brendan, actually. I saw a tweet
a late
about that.
checkout
And
fee
it's
or
like,
something.
no, it
from
turns
the-
out
yeah.
they had a buffer.
And I think they have decided that they're going to roll back SLS.
Yes.
Yes.
Yeah.
Oh, yeah. There was a lot of like, we have 3 options. One of them is this and this and this, but they're going to roll it back and then they'll bring it back out.
That's the NASA's new big rocket,
Yes.
which did not pass its wet dress rehearsal
Not yet.
yet.
Yeah.
And they've decided they're rolling it back to the VAB before they make another attempt. They
Yeah.
made 3 attempts.
And they got like
They made some progress, but
Yeah.
they had various leaking issues from
valves,
here and
man.
Yeah.
there. Yeah.
They'll get you.
But this is exactly what
That's what
is
the test is
expected.
for.
That's what tests are for.
Yeah.
So we're all chill about it.
Yeah.
Yeah.
Is there like a liquid hydrogen joke in there? Being chill about it?
Oh,
Ah.
liquid hydrogen is quite cold. So we don't know when the
I can't
next
condone
wet
that
dress
behavior.
rehearsal will be, which means we also don't know when the launch of SLS will be.
Yeah.
So
I think there's
all these things are still
yeah.
hanging out there. We also don't know, if you may remember, we're getting close to the midpoint of 2022. And at the end of the last year, Elon Musk, Hannah's dreamboat and favorite person,
Don't even joke. I'm so insulted. Carry on. Sorry.
predicted that there would be 12 launches of the super, whatever it's called, with Starship on top.
Starship. Super heavy.
Super heavy.
That doesn't sound
no,
right either. Why
I
are,
don't-
we're pulling a gym right now.
I know. Well, they keep changing the name.
Well, I
on
don't
that
know
thing.
what you're saying.
I think Starship is just the. Isn't Starship the piece on top?
Yeah. But I think when it's all integrated, they just still call it that.
Anyway, SpaceX has a giant rocket, stainless steel giant rocket, very Flash Gordon-y.
Yeah.
You know who Flash Gordon is anyway, Hannah?
I heard of it.
Cheapers. And he had predicted 12 launches in 2022. We're still waiting on the first one. At least one holdup has been environmental impact statements and
Yeah.
approvals from the FAA for launch, because that's they've been doing their test launches from their spaceport in Boca Chica, Texas, which has not been the site of orbital launches in the past.
It is the super heavy.
The Super Heavy with a Starship on top.
Yeah.
And I think at the same time, SpaceX is working towards setting up a launch system for that here in
Yeah, they're
Florida.
working on a pad here in Florida.
And so it'll be interesting to see whether or not the first launch actually takes place from Texas
yeah.
or here, and
Yeah.
when it
And
will
when that
happen.
happens.
Because they're amazingly behind Musk's initial predictions.
Yeah. And speaking of environmental impact statements, shout out to Earth Day today.
Oh, yes. I hope you've all picked up your trash today.
Yeah, and maybe made a little less of it today.
I brought my lunch in.
Good job. Yes. And you biked in?
And I rode my bicycle in.
Perfect.
Yep.
I'll do something good later. I need to. I haven't really thought about it.
Do something good later.
I'll filter some carbon into the atmosphere.
Yeah.
Okay,
So
Decadal.
the Decadal Survey, the National Academies, and there are several National Academies, but one of them is the National Academy of Sciences.
And engineering and medicine, technically. It's like all in the names.
Oh, I thought, or is it just, it's a single National Academy
It's
of all those,
NASM.
it's all those things?
Yeah.
Oh, I see. I thought there was like the National Academy of Sciences and the National Academy of Engineering.
I've always seen it as NASM.
Okay. In any event, the National Academy produces, at the behest of NASA,
Yes.
I believe,
Yes.
every 10 years, they assemble some illustrious panel of experts to produce a decadal survey that's basically the prioritized wish list
Yes.
for whatever the field is. Like there's
Yeah.
a planetary, there's an astrophysics.
Yeah, there's an astrophysics one. It's really an interesting process because it's like, what does the community of planetary scientists think should be the priority for the next decade of space science and exploration? So it's really a way to say, like, here NASA, here's what the community thinks the priorities are. Here, Congress, here's what the community thinks the priorities are, and here's what should be funded. Here's places we need more funding. Here's missions we think might be feasible and should happen. So
and it really works. Like
yeah, for the most part.
Those things are pretty much followed. The last Planetary Decadal Survey, the top two flagship priority missions were a Mars rover to cache samples for return, the Perseverance rover, which is now roving around Mars.
And was the answer to a Jeopardy question last week. Very
That's
cool.
right.
They got it wrong.
And a mission to Europa.
To Europa.
The Europa Clipper mission, which is not yet launched, but which is underway. Guess what was third
Venus?
on that list of flagship missions from the last Decadal Survey?
A moon?
No,
I don't remember.
Uranus.
Really?
Yes.
That's
a
right.
Uranus flagship mission, which is now
Number
first.
one.
A number one.
Since the
Because the other
previous
two.
and nothing, no new mind-blowing discoveries about, oh my gosh, there's some other thing that we didn't even know about at all has come into play. And so Uranus has moved up to number one on that list.
Yes.
And number two on the list.
Is it Orbilander? Which is just
Right.
like, why did they come up with that word?
I don't know.
So they do like 2 years in orbit and then land on
What
the
is an
surface.
Orbilander?
So this is an Enceladus Orbilander.
Which I'm super fond of Enceladus,
Yes.
I have to say.
Yes.
This is Saturn's moon that has geysers.
Yeah.
That produces the E-ring, and it's
And we've talked a lot about all of these icy moons and their
subsurface
brines
oceans.
Oh, yeah,
and
you've been on a
everything
brine
else. Love a
kick
good brine.
Enceladus is the one of those moons whose subsurface ocean literally is spewing out into space.
And they've found like they think it's got like salts in it, which is the interactions between like water and rock, which would generate potentially some ingredients to support like life. And so they want to be able to detect that from orbit and then also land and sample these materials as well.
So
Yeah,
what is
so
that? The
the
Orbilander thing?
Orbilander will analyze fresh plume material from orbit and during a 2-year landed mission. Its main science objectives are to search for evidence of life and to obtain geochemical and geophysical context for life detection experiments.
Okay.
Yeah. So it'll orbit a little bit, go through some plumes, fly through
Right.
some plumes. Ooh, that's probably good for like SUDA. And then, which is a instrument, never mind.
Okay.
Instrument from our colleagues.
Okay.
And
At first, I wasn't
then
sure
land.
whether you were still on the science theme. You were reacting to the fact that I just burped
no, I didn't. No, yeah. So that's exciting.
because you said "ooh" right after that.
A thought, ooh.
Yeah.
Yeah. So
Okay.
that's
So
exciting.
it would
Enceladus.
orbit and it would have a 2-year mission at Enceladus.
I think a 2-year landed mission, so it would orbit
Okay.
for a little bit and then probably do some like, where are we going to land? And then land.
Okay.
And what I was going to say, what I find really cool is they've set like a target arrival time of early 2050s, which is when it would have optimal illumination of the South Polar region,
Oh, yeah.
which I think is really interesting. So,
Based on where Saturn is in its orbit.
exactly.
Yeah. So Saturn's year is 30 years, 30 Earth years long. And when Cassini got to Saturn in 2004, we were just after the sort of main illumination of the South Pole. So it was heading towards whatever. It was heading towards northern spring heading towards spring. And so we just passed the sort of southern summer solstice time period in 2004. So early 2050s seems odd to me. My math isn't working out, or my maths.
Your maths. Thank you.
Are not working out correctly just there, because I'm pretty sure the the Cassini final mission phase was called the Cassini solstice mission, and it was meant to see the northern summer solstice, which was around 2017.
Okay.
So 30 years plus that is 2047.
Okay.
So then you would need
but that's
either
for northern.
yeah, I know. So you need to subtract 15 years or add 15 years to get to southern.
Yeah, who knows? Okay.
So 2050 sounds weird to me. Maybe I'm messed up.
Maybe you got your maths wrong.
Yeah.
My maths or my memory. It could be my memory also, but we'll check that.
Check that out.
But yeah, so that mission is
And why
secondary.
do we want to see the southern pole? That's
because
more interesting to our readers rather than me trying to figure out what day this is all happening.
That's when all the plume
they're probably
is.
listeners rather than readers, aren't they? It's Friday afternoon,
readers.
folks.
Dear readers, we haven't even had any alcohol yet.
I know.
All the plumage coming out of Enceladus.
Right.
It's like a beautiful peacock, all that plumage.
Enceladus South Pole's where these geysers are, yeah. So we definitely want to be able to see that. Okay, cool.
But this is secondary to the Uranus orbiter, which I think is really cool.
And what's the time frame for that?
Sorry?
The time frame for the Uranus orbiter?
Initiation in the decade 2023 to 32, and depend. So they've got different options. So they've got launch opportunities 2031, 32, which would use a Jupiter gravity assist.
Okay.
But then if they were to launch between 2032 to 38, then they would use a gravity assist from various in the solar system things.
Oh.
So
and
it gives them
what's the
options.
flight time to get to Uranus and that?
It's many years.
Yeah. So
I
Voyager.
want to say it's like 10 to
I
10-ish?
would predict
15-ish?
I would predict over 10.
14? I forget.
New Horizons got to Pluto in a hurry.
Yeah.
It went on a very direct path, partly because it was a pretty tiny spacecraft as these things go.
Yeah.
Voyager got to Uranus also pretty fast. It had gravity assist from Jupiter and Saturn, which we won't have available for our next trip to Uranus. And if you're doing inner solar system gravity assist, that means you're tootling around for a year or two to fly by Venus and Earth. So it's sort of a couple of years before you even leave the Earth really for good.
I'm trying to remember when I did my summer school and we had a Uranus mission. I feel like it was like 14 years or something. Because I remember one of the problems was, so to do a Uranus orbiter, typically you're going to need some radioisotope power.
Yes.
And most of the systems we have, like the energy, the Stirling engines and the little generators that use radioisotope power haven't been tested for lifetimes of like 18 years or 20 years that you need to get there and then do the science.
And then operate for a while.
Yeah.
Right. So this would, unlike Voyager, be a Uranus orbiter.
And probe.
And a probe into the atmosphere of Uranus. Okay, pretty interesting.
Yeah,
so
insert jokes there.
I like that it says a multi-year orbital tour as if it's like a vacation.
Right.
Orbital tour.
Right. Okay, so let me actually give you your trivia questions, which are all about Uranus.
And then we can talk
I'm
more
not going to say the word the other way
Great,
for the rest
I
of the show.
appreciate that.
Just to let everybody know, you don't actually have to make that sound.
Yeah.
What?
You've got other options.
You've got other options. So I'll give you the trivia, then we'll talk about the specific things that the Uranus orbiter and probe mission would do.
Okay.
So we have 4 questions. They may
Multiple
be
choice.
2 of them are multiple choice.
Okay.
And they may be I have high hopes for both of you on these. When was Uranus discovered? Your options.
Oh, shoot. I should know this.
This is terrible. I said when, but what I meant was by whom.
Oh, okay.
Who discovered Uranus? Sorry.
This is multiple choice?
Yes, it is.
Okay.
Who
great.
discovered Uranus? Your first choice. It has a visual magnitude of 5.4. It's been known since ancient times, so unknown ancient observers of the sky.
Okay.
Galileo.
Okay.
Tycho Brahe.
Okay.
William Herschel.
Okay.
Percival Lowell.
Okay.
Those are your choices for who discovered Uranus. The second one is, what is the family relationship in Greek mythology between Uranus, Cronus, who is known to us better now as Saturn,
Yes.
and Zeus, who in planetary terms is Jupiter. So Jupiter, Saturn, and Uranus are all Greek gods.
Okay.
They're related to each other.
I've read this before.
Basically,
in
your
there
choices are all of the possible configurations of father, grandfather, father, son.
Okay.
So who's the grandfather, who's the father, who's the son?
Oh, man. Okay.
And between Uranus...
We'll come back to it.
Okay.
I mean, that's it.
No, I was going to ask what the Greek names were again, rather than the planet.
Cronus is for Saturn, and Zeus for Jupiter.
Okay.
And Uranus
Zeus
is just Uranus.
And Uranus is just Uranus.
Okay.
Yeah. So that's it. The other questions we'll come back to at the end. So let's talk about this Uranus Orbiter Probe mission.
Oh.
So what's it going to...
I was going to talk about other things in the Decadal, but that's fine.
Well,
Talk about this a little bit more.
I was wondering, because I don't know a lot about
I do
the
want to
outer
hear about
solar
other
system.
things in the Decadal.
I don't know a lot about the outer solar system or why people are so interested.
Okay.
Or is it not?
You and I have remarkably little in common, as it turns out, Hannah.
I like rocky bodies rather than all these gas giants and icy things.
Yeah. Although we did have a good time at that volleyball match.
Yeah. Okay.
So
Sports.
we have one overlap there.
A very small crossover on that Venn diagram.
Venn diagram.
But all of these exoplanet discoveries and things, a lot of these planets that they're discovering are Uranus-like, Neptune-like objects.
Giants.
So it's interesting. Yeah. So Uranus, like, people have been interested in Uranus and Neptune, which are now called ice giants, which is a newish thing, I feel like.
Yeah.
They were still lumped in with just like the gas giants when I first learned back when I was a kid.
Yeah.
But they're very icy. Right, they're like
not
part of their
as
defining
gassy as
feature is that
Jupiter and
they're
Saturn.
very cold and they're more icy than just gassy.
Right. For Jupiter and Saturn, the majority of the mass in those objects is gas.
Yes.
And for Uranus and Neptune, the majority of the mass is not gas, it's solids.
Solids, yeah. And they're pretty enigmatic. They have so Neptune, right, has really complex wind structures. And Uranus does to some extent. Uranus is tilted.
Yeah, it's got a really funny tilt.
At this crazy angle.
97 degrees.
Yeah, which means, and it has rings, and it has, its magnetic field is tilted with respect to...
It's tilted with respect to everything else.
Everything else, because Uranus is tilted, but its tilted
magnetic
field
with
is also off of
tilt.
that.
Right, yeah. Very complicated magnetic field.
Complicated, and it's off-center, too.
Right.
I think, yeah.
And we have so little information from it. The only mission that has been near to it is Voyager 2, which was a flyby.
Right.
Yeah. And there's,
which was the bulk of my dissertation, was analyzing Voyager 2 observations of Uranus rings.
Yeah.
So this is why you care so much about the outer solar system.
I mean, that's what I've been working on for a while. Yeah. It has an interesting ring system.
Yeah.
As a planetary rings person.
And a lot of people forget about it. They always think of Saturn, so it's nice to...
It has very narrow rings, and narrow rings are intrinsically puzzling.
Yes.
Because nature abhors a vacuum, and right next to a narrow ring is vacuum. And so the nature would say, spread into that vacuum narrow ring and become a broad ring.
Yes.
And so that's an interesting puzzle.
It says, nay, I shall not.
Neptune also has some narrow rings, although Uranus's ring system is a little bit more extensive, but Neptune's has these funky arcs. One of the other funny things about Uranus and Neptune, like you mentioned that they've been puzzling for a while. Yeah. Once you get to one of the puzzles is there's this sort of idea we have about how to make a planet like Jupiter, and it begins by making a planet like Uranus and Neptune, and then inevitably it becomes like Jupiter or Saturn because it has enough mass to capture all of the abundant gases and become a gas giant. So anytime you see an ice giant like Uranus and Neptune, like, how come it? How did it manage to get to that stage and not go all the way?
Yeah.
So if we can, I was going to say, so if we can understand some of these processes, then this will give us ideas about what's going on in all of these other exoplanetary solar systems and whatever.
Yeah, and that's actually used as an argument a lot these days, and they highlight that when they talked about the Decadal is that, like, yeah, we now have all of these exoplanet systems with, some of them have hot Jupiters that are really close in, but a lot of them do have these sort of Neptune-sized objects that are still relatively close in.
And so how big are we talking when we're talking about Uranus and Neptune, these ice giants?
Yep.
Okay, so I'll answer. It was a
Ask our
rhetorical.
friend Google.
Or the outer planets person in the room, which is me. So they're about 4 times the diameter of the Earth.
Yeah.
And 25 or so Earth masses.
That's smaller than I thought.
Yeah.
Yeah, Neptune is slightly more massive than Uranus. That's also been a puzzle because it's further out.
Yeah.
In our sort of normal, simple explanation.
But there's all that other stuff out, like there's a Kuiper belt out there, so maybe it makes sense. I don't know.
Well, the Nice model provides one explanation for it, which says that actually Uranus, which is now the 7th planet from the sun, may have been the 8th planet.
Oh, they reorganized.
When they formed, and following a major gravitational instability between Jupiter and Saturn, the gravitational perturbations from those two big bullies
kicked them out.
Reorganized the solar system in such a way that Uranus and Neptune swapped positions. That happens in something like 50% of the computer simulations that they do of these instabilities, which is kind of cool.
Yeah, it's
then we get
crazy.
Then we get this planet that may have been even the more distant planet, a little bit closer for observation. So.
And they both have interesting moons. Additionally, we haven't mentioned those yet, but they have interesting moons.
One of my favorite moons in the solar system before Cassini got to Saturn and saw Pan.
Is it Miranda?
It is Miranda.
Yeah. That thing is messed up.
It is.
It is a messed up moon.
What? Why?
It's the most effed up body because I'm in the solar system.
I think there are so many moons out there. I forget.
But you like rocky objects.
I do like rocky objects, but that's a lot. So I just need to. I'm interested. I'll just get the names wrong sometimes.
Well,
so Miranda looks like here.
It has this crazy. It has these crazy.
Yes.
Racetrack and chevron features.
Yeah.
That are just plunked together. It's a small moon. It's a few hundred kilometers.
But it's still spherical, which makes it feel like it's got its...
It's big enough to be round.
Together.
But it looks like somebody put a puzzle together incorrectly or took pieces from like 4 different like moon puzzles.
Yeah.
And scrambled
it's
them.
Like when we got these
together.
When we got these images back from Voyager, we just or most of the images Voyager, did we just like assemble it wrong?
Right. Yeah. Was this mosaic put together incorrectly? Because
what was the data loss?
It looks like somebody took the pieces from a normally cratered body and then something from sort of like an Enceladus kind of thing, and then who knows what else is going on with these canyons.
Aliens.
Giant cliffs on this little tiny moon. Yeah. It's pretty cool. So lots of cool things to study there. But as you mentioned, there's other targets or subjects.
There's other things in the Decadal.
Other things in the Decadal,
that we should be doing besides Uranus and Enceladus.
Yeah, so there's other missions that they outlined. So they outlined the New Frontiers, which is sort of the next cast down, and they sort of outlined 8 mission themes for the next call, so people could propose to that. So a Centaur orbiter and lander. So Centaurs are asteroidal cometary type objects that are pretty enigmatic as well. There's a Ceres sample return mission.
Yeah, Centaurs are sort of in between, out beyond Jupiter.
Yes.
But not beyond Neptune.
Yes, yeah. A comet comet surface sample return, so a bunch of sample returns, which I think is like, it makes sense for that to be a next stage. An Enceladus multiple flyby, so maybe that, I don't know.
It might be as like in case it has to be descoped or something.
Yeah, or it could precede the Orbilander. No, that's not an Orbilander. Oh yeah, that's the Lunar Geophysical Network, which I'm excited about and glad it's listed there. A Saturn probe, a Titan orbiter, and a Venus in situ explorer. And then the smallest missions, they said we should increase the cost cap, but they also highlighted the fact that we should have a Mars sample return mission, and that should be a high priority, and it should happen soon. So do not delay it.
And that's to collect the samples that the Perseverance rover is already basically caching.
Right.
So we've got the rover on Mars already. It's collecting these samples in anticipation of there being a mission to come and collect them. There was concerns about budget. So they're making recommendations to look if the budget needs to increase because we need to build like a a facility to store these samples when they get back to Earth, then they've basically recommended like you have to find a way to make this budget happen. So very pro sample return from Mars, which would be cool.
And one of the challenges with that is there's been plans for international participation in the Mars sample return, and like from ESA and from some other partners. So it'll be interesting to see like if they push forward with it as well and how that works.
And especially since because there was another Mars mission that was kind of being in development, which was it's an orbiter, the International Mars Ice Mapper, which is designed to search for icy deposits and to both search for life and find resources for a future Mars base. And that is a team that I'm on, which is the measurement definition team, trying to decide what it is that we want to measure and detect. And the funding for IMIM was cut a few days before the Decadal came out. So no more Mars Ice Mapper for now.
Go ahead.
And then they also... Did you have a question about that?
No.
Okay. So then they also say that there should be this really cool mission called Endurance A on the moon.
We love the moon.
We do love the moon.
Yeah.
You too love the moon.
We love the moon.
Which is
I like the moon.
Which is it's a super interesting concept because there was the study did two different ideas. So Endurance is a rover that will drive around in the south polar region of the moon.
Can I talk about which region?
Sure.
The South Pole Aitken Basin, which is really cool.
SPA.
It's like this giant impact that it kind of dug up this deep material from inside the moon.
Yeah.
So going there would like teach us so much about the interior of the moon.
And it has something like 1,000-kilometer range or something, which is important because SPA is huge and there's so many different types of regions on it. You want to collect samples at lots of different areas.
And we've talked about there's a lot of interest in the South Pole because we have these permanently shadowed regions and there's
ice.
More oxygen and hydrogen available. And also, interestingly, where you have permanently shadowed regions, you can also have sort of permanently illuminated regions on hillsides for solar power.
Yeah, you have these craters in the poles which get the sun is like really coming in at a super horizontal direction. So
it's shining right on the cliff face.
Right on the cliff face, you get permanent illumination, and in the crater, you get no illumination.
Right. So you put your solar panels on the walls, and then down on the floor, it's dark all the time where there's ice. So you've got the electricity and your mining set up there. And those particular craters live within the larger Aitken Basin. Is that right? So like Shackleton Crater, which we talk about a lot. Is that part of this Aitken Basin region?
Does SPA overlap with Shackleton? So Shackleton is like right on the bottom of the poles. And SPA is sort of...
How big is SPA?
Oh, gosh. I don't have a number, but it's so it's called the South Pole Aitken Basin because it's in the South Polar region, but it is shifted to like one side. So it's not directly over the South Pole.
It is in SPA.
It is in SPA. Oh, cool.
SPA is really, 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 really big.
Yeah.
So it encompasses most of the...
is going to be bigger than a crater. And
I just didn't know how wide that basin extended across.
Yeah. If it's called the South Pole Basin, it's got to have Shackleton in it.
It's true. I think it basically goes from the South Pole to the Aitken crater, which is why it's called South Pole Aitken.
I see.
Right.
Oh, okay. Interesting. So there's a crater called Aitken.
I think so. I just made that up, though.
That's after the American Idol guy?
Clay Aiken, yes.
Yeah, okay. I also have an update on my maths and my memory.
Okay, can we finish talking about endurance really fast?
Yeah, go on.
Yes.
So there was 2 studies they did, and one was that it would be a robotic sample return. So it would go collect all its stuff, then bring it back, and then we'd send another thing, and it would go pick it up and bring the samples back to Earth. But the other version is called Endurance A, and that's using Artemis. And so the little rover would drive around and then return back to an Artemis landing base, and the humans would bring it back.
Come and pick it
and
up.
that actually saves a lot of money, at least on the planetary science side, because
Right.
you're assuming the humans are already going to be there.
Right.
And human exploration can pay
And
for
then
it.
they can do something,
And they pay for the launches.
helpful.
Yeah.
Right,
Yeah.
And the Endurance name for that rover chosen because
Because it's after Perseverance. But also, I think because South Pole, right?
Because Shackleton's ship was
yes.
called Endurance, which has just recently
Yeah, they just discovered the ship.
just recently been discovered in remarkably
It's beautiful.
spooky, eerily well preserved condition.
Yeah.
my maths and my memory were correct. So something's messed up with this 2050s plan.
Oh.
The summer solstice at Saturn was just before Cassini got there in 2004. It was in 2002. The year is 29.7 years long. So 2002 plus 30 is 2032.
What if it launches
And then
in
the
2050?
next 30 is 2062. So if it launches in 2050 and you get
No,
there...
it's not launching in 2050. It's
Well,
arrival.
I'm saying it should.
Oh.
Yeah, 2050 is not a great time to be there.
It's not a great time to be there, is what we think.
It's not the
What Josh
worst
thinks.
time, but it's you're approaching.
Too bad the Decadal Survey didn't ask
illumination
you.
is coming into. I know they know all this stuff, so it's maybe that's when sunlight first begins shining on the South Pole. You don't need it to be at its highest point, but its highest point on the South Pole would be in about 2061 next time. 2061, 2062 time frame.
Glad we came back to that.
Just wanted to clarify, my
Yes.
maths were okay.
Good job with your maths.
And my memory, which I increasingly worry about since I referred to our listeners as readers recently.
Yes. And we'll probably talk more about the decadal over time because we have 10 years to talk about it.
That's right.
But like the big science part of it is also defining sort of the science themes for the next decade, which is important for us to read because like when we write proposals, we have to say this is important in the decadal.
Right.
So the big themes are origins, worlds and processes, and life and habitability.
Sounds
And
good.
I also would like to mention that they've included this planetary defense section as well. So trying to have a better, they want to survey the potential threats, basically,
Right.
of near-Earth asteroids, near-Earth objects, and those that pose the highest probability of a destructive Earth impact, so that we can prepare better, basically, which I think is really cool.
Cool.
In case of something like deep impact.
Exactly.
Yeah. Which, bringing it back to MegaCon, which we'll talk about, which we'll be speaking at in a few weeks.
Great.
Yeah. All right. So who discovered Uranus? Your trivia.
Herschel?
Yeah, I want to go Herschel.
You are correct. William Herschel,
us.
from his with his homemade reflecting telescope in his backyard
England.
and more specifically,
A town in England.
cheeky, Bath.
Oh, okay, that's familiar.
Yeah.
I know the image of his telescope on the roof.
17 on March 13th, 1781. He initially thought he had discovered a comet.
Yeah.
So he wasn't overlapping with Jane Austen just yet. I don't think he was a little before Jane Austen time, but the same town.
Interesting.
Since its discovery, how many times has Uranus orbited the sun?
When did you say it was discovered again?
1781. Okay, you'll do some maths.
Yeah, we'll do some math to think about that. So it's been like
It's his Jeopardy rules. You mentioned Jeopardy, so you only have 5 seconds.
3.
4?
3.
Oh, nice.
It'll be 3 full orbits in 2033. Close enough. So at 84-year orbit.
84.
What is the family relationship between Uranus, Saturn, and Jupiter? Mixing our Greek and Roman mythological names here.
So I
Who is whose father?
think
In terms of the Greek names, I think it's Kronos, Zeus, and then the other one.
You think Kronos is the granddad,
Yeah,
Jupiter is the dad,
yeah,
and Uranus is the son.
yeah.
I think Zeus, Kronos, Uranus.
You think Jupiter's the dad,
Yeah.
Saturn is... So you think Jupiter's the granddad, Saturn's the dad, and Uranus is the son.
Yeah.
Uranus is the granddad.
That's what I was worried about.
Oh, yeah. I didn't know.
I
how
just
it
don't
was.
know where Uranus fits in.
Uranus is the granddad, Saturn is the dad, Jupiter / Zeus
were close.
is the
Oh,
son.
so I got the
close.
Kronos Zeus thing was right. It was Uranus that
Yeah,
I
you just
forgot.
had Uranus the wrong.
Well, you
way.
both had Uranus as the son, and Uranus
Yeah,
is
we
the
were-
granddad.
yeah,
But she
Yeah.
had the other two in the right.
I recognize the Kronos Zeus thing.
Yeah.
Yes, I think Zeus popped out of Kronos' head.
I remember Kronos was really mad at Zeus.
Yeah, probably because he popped out of his head instead of being born a proper way.
Born a proper way.
Like our baby astroporks have been
Yay.
born. Yeah. The final question, actually, this isn't really I guess I can make it a question. Averaged over the Uranian year, we mentioned its funny tilt.
Yes.
So it's nearly on its side, meaning that at a certain time in the year, the North Pole is pointed straight at the sun. And then half an orbit later, the South Pole is pointed straight at the sun. And in between, it's barbecuing like the Earth and other planets normally do. If you average over the Uranian year, Which receives more solar energy, the poles or the equator? Also, Jeopardy rules on the timing. No maths.
The
I'll go equator.
poles.
It's the poles.
Because they like point during
However, the equator is hotter, presumably due to internal heat sources, but it's not fully understood.
Uranus, you cray.
One of the many mysteries that the Uranus orbiter probe.
So this is why we need to send a mission there.
The Uranus orbiter probe will resolve when it gets there. While it may have felt like an episode of Schoolhouse Rock, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you 5 baby astroquarks someday, maybe.
That's a lot of pressure.
Be sure to follow us on Facebook and
another 4
Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you'll find shorts and a music video. Catch up on old episodes, but not the one I did today.
Okay.
Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At @walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Drusick. Production assistance is provided by Logan Basinger. Thanks to our listeners in Colorado and around the world. Stay safe. I'm Josh Caldwell.
I'm Maddie Dove.
And I'm Hannah Sargent.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
Uranus.
Uranus.